All right. We are going to talk today about the basics of geometry. Now, in geometry, there is a lot of new vocabulary. So, the beginning of this, we're going to be going over a lot of new terms, and it's important that you get the definitions of them down. Because if we start to speak in geometric terms and you don't know the vocabulary, you won't know what we're talking about. Just like if I started to speak in some foreign language and you didn't know that foreign language, you wouldn't have any idea what I was saying. All right. So let's take a look at the first note packet. Now you should have this note packet as well, and you should fill it out as you are watching this video. So we're actually going to hold off on the warm up on describing the picture. We're going to come back to that after we've learned some vocabulary. So the first word that we want to talk about is a point, right? So a point is a location. Right? So a point, although we see it here, it's really just signifying a spot that you want to refer to. All right? It actually has no size or shape. So it's really kind of an imaginary thing. Here on this paper, you don't see a point, but there's actually one there, right? There's a point anywhere I want it to be. It's kind of an imaginary thing. All right? Always use a capital letter to name a point. So here you can see this is point A. I've named it with a capital letter. Another example here would be point B, point C, point F, right? Whatever you would like. All right. Another word that you will come across a lot in geometry is a line. So a line is made up of any 2 points. So anywhere I have 2 points, for instance, I have 2 points here, I can put a line through them. All right. I also have 2 points here, B and F. I could put a line through those. So between any 2 points, I could make a line. So any 2 points form a line, but a line is actually made up of infinitely many points. So for instance, here you have this line here that is made up of 2 points, but in between there are really just a whole bunch of little points all right one next to each other. So a line is really made up of a series of points. Let's actually change that to a series of points. And just like a point has no size or shape, a line really has no thickness or width. So although we draw it, it has some thickness or width because otherwise we couldn't draw it. But when you're really talking about a line, again, it is a little bit of an imaginary thing. You're always going to name a line by any 2 points and only 2 points on the line, or you can use a lowercase script letter. So, for example, I could call this line here, I could call it line XY, and I'm going to put a little line symbol above it. Or I could call it line N. So those are the 2 ways that I could describe this line. However, because a line actually does not have direction, it goes infinitely in this direction and in this direction, I could also call this line YX. All right. Now, points that lie on the same line, so X, Y, or if I added another one in here, Q, all those points are called collinear. So collinear on the same line. It's got the word line right in it. And non-collinear points are points that do not lie on the same line. And there has to be at least 3 of them. Well, why is that? Well, let's look. If I put a point, I don't know, let's call it F, and I put another point over here, let's call it C, I can put a line through these points because I can put a line through any 2 points. So they would be collinear. But if I added a third point, let's call it point B, well, now these 3 points are not collinear because I can't put one straight line through them. I can put a line through BF, and I can put a line through BC, but I can't put one solid straight line through all 3 of them at the same time. So I would have to say points F, B, and C are non-collinear. All right, let's take a look at the next page. All right, now we can talk about a plane. I always think of a plane as like a piece of paper. That's kind of how I imagine a plane. All right, so a plane is basically a flat surface, just like a piece of paper is. And it's made up of an infinite number of points. So just like a line is made up of a bunch of points, this plane is really just kind of made up of a whole bunch of points all over the place. Any 3 points now make up a plane. So 2 points made up a line, 3 points will make up a plane. And a plane extends indefinitely in all directions. So I'd like to think of a plane as a piece of paper, but again, it's not really just a piece of paper because it doesn't have a set shape. It goes on and on and on in all directions. We can name a plane by any 3 non-collinear points. So I could name this plane over here. I have J, K, and L. So I could name this plane K, J, L, or I could name it plane L, K, J, right? The order of the letters don't really matter. You could name it any way you wanted to. But be careful because you notice this P here does not have a point next to it. So this P, this kind of cursive P, is not actually a point. It is naming the plane. So you can use an uppercase script letter to also name this plane. So I could also call this plane P. So just be careful when you're naming a plane that you don't use P as one of your points because it's not really a point. It is the name of the whole plane. Just like I have collinear and non-collinear points, I can have coplanar and non-coplanar points. So points that lie on the same plane would be called coplanar. And points that do not lie on the same plane are called non-coplanar. And in order to kind of think about, well, what point would not be on the same plane, you almost kind of have to think about something in 3D. So, for instance, if I have this piece of paper right here, right, this is my plane. If I had a pen or a pencil that kind of went perpendicular to it, then the tip of my pen up here would be non-coplanar because it would actually be above the plane. Or this little point here where I click my pen, when it's down here, it's underneath the plane. So again, it would be non-coplanar. All right, moving on, we have intersecting lines in planes. So here I have 2 lines, and you can see they meet at point P, and 2 lines will always intersect at a point. No matter how I put them together, they will just intersect here at a point. Unless I overlap them, of course, then they're on top of each other. 2 planes intersect at a line. So you can see here is a plane kind of going up like this, and there's another plane here. So you can see these are kind of perpendicular to each other, if you kind of think of them kind of going like that, or if you look at pens, they kind of go like that. And so they intersect right here at this line. And so two planes will always intersect at a line. Segments. A segment is very similar to a line, except that a line goes on and on and on in either direction. And you notice there are no arrows here on this segment. So a segment has a specific length. So the line segment, AB or AB or AB, and you can put a little line segment over it. So this is going to be different. If I wanted a line, I would write it AB and I'd put the line symbol over it. But if I want a segment, I'm just going to put this without the arrows on the ends. So we can call it a line segment or simply a segment, really referring to the same thing. And again, you can see it's written as AB with just that little segment symbol over it. And it consists of the endpoints, A and B. So one end is A, one end is B. All points on line AB that are between A and B. And note that I can call this AB or BA, again, because it really doesn't have any direction. I can refer to it in either way. Which brings us to the next thing we want to talk about, which is a ray, which does have direction. So here's a ray. You can see it starts at this endpoint A, but it goes on and on and on and on in this direction. So the ray AB is written as AB, where your endpoint will always be the first letter. So A is my first letter. And then the arrow should be above the second letter, which is the one that goes on and on and on in the direction. So this would consist of all points starting at A and going towards B and on forever. This one here, this second one here, is going to be a little different because now my endpoint is B. So I'm going to call that B. I'm going to always start with my endpoint and then A. And my arrow is still going to go to the right, but you can see that the arrow here is closest to the A. So the arrow here is going to be closest to the A here. So this would be ray BA. Unlike a segment where I can call AB and BA is the same thing, ray AB is not the same thing as ray BA because they go in opposite directions. However, that brings us to our last term for today, which is opposite rays. So you can see if I put these two rays together, if I started here with A and went over to B, but then put this one on top of it, here A and over to B this way, these two rays are going in opposite directions, so we would call those opposite rays. So if point C lies on line AB, so here's line AB and C is on it, then either CA, so let's do it in two different colors. This could be ray CA and ray CB. This would be ray CB. And you can see that those are opposite rays. All right, well, that's a lot of vocabulary for one day. So go back and kind of take a look at your warm-up picture and see if you can find some of these points and lines and planes and intersecting planes and all this vocabulary in this picture. I hope this helps.